All right, gentlemen. So far we know how to graph a quadratic equation. We know how to find the axis of symmetry. We know how to find the vertex, the y-intercept. We know just by looking at the quadratic equation if the graph is going to point upwards or downwards, okay, whether or not the a, which is the coefficient of x squared, is positive or negative. We also know how to find the exact solutions by either factoring and using the zero product property or by completing the square. Now there's one formula that will solve every single quadratic equation or function. It may give you perfect, beautiful numbers. It may give you ugly numbers. It may tell you that it's no solution, but it will always solve the equation. And it is called the quadratic formula. It is the best way to solve a quadratic equation because you can use it on any quadratic function. Now, let me qualify that. If I have a very simple quadratic function that I can factor, I'm going to factor it. If I can solve it using square root, I'm going to go ahead and solve it using square root because it's a lot quicker. It's a lot easier and a lot more efficient if you do solve it by either factoring or by square root if they're easy. I'm really quick with completing the square, but sometimes I just don't want to deal with it, so I go to quadratic function, a formula. A little warning, if you think you're going to use a quadratic formula for every single test and quiz question, you can. Absolutely 100%. You probably will not finish the test though. There are some quadratic functions out there that the quadratic formula was designed for. For example, 0.72x squared minus 12.5x minus 36.75. There's no way on earth that I'm going to complete that square. There's no way on earth that I'm even going to attempt to start factoring that. That is going straight into the quadratic formula. So what is the quadratic formula? Okay, first of all, it's based on the quadratic function f of x or y equals ax squared plus bx plus c. Remember, this is a quadratic function. X must be squared. The a, as we know by now, is the coefficient of x squared. And if it's positive, the graph will point upwards. If it's negative, the graph will point downwards. C is my y-intercept, the y value when x is 0. And b we use to find the axis of symmetry. We can plug in the a, b, and c into the following formula. Negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. That is a quadratic formula. I'm sure you saw this in Algebra 1. Now we're going to work with it again, so it should be pretty easy. And with this formula, absolutely now you can solve any quadratic function. Yes, sir?
Are we allowed to use a calculator?
Okay, the question was, are we allowed to use a calculator? What's going to happen here is the following. You're going to go ahead and solve this without using a calculator. You're going to give me the answer in the square root form that it gives you. If you can calculate it correctly on your calculator after showing me that you know how to do it by hand, I will give you extra credit. Okay, not a lot, but some. Just to show me that you have proficiency with your calculator, because technology, whether I like it or not, is important. And you have to know how to use a calculator. The thing I don't want is just a bunch of fingers plugging in, plugging in, plugging in, and then all of a sudden I have all these answers and no work. So you're going to have to do this by hand. There's no choice, unfortunately. But we're going to go through it right now. I'm going to show you how to do it. Does that make sense, gentlemen? You're welcome. Does that make sense? We're good so far? Okay, let's do this. Example 1. Okay, let's see what we do here first. We know by now that we always set these equal to 0. So I'm going to have x squared minus 12x minus 28 equals 0. Remember what I said always, can you factor it? If you can factor this, factor it. Okay, you cannot. If I wanted to, could I complete the square? Yes. And we're going to work on that completing the square because that's a skill you're going to have when we're graphing quadratics and conic section in vertex form. So whether you like it or not, guys, you're going to have to learn how to be masters of completing the square. Okay, we'll go over that tomorrow, though, a little review of that. So we cannot factor this. I want to use the quadratic function or formula. So negative b, so that'd be a positive 12, plus or minus the square root of b, which is negative 12, squared, plus or minus, not plus or minus, minus 4 times a times c divided by 2a. Negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. Now, this math here you have to do by hand. This is going to be 12 plus or minus the square root of 144 plus 112. Is everyone with me? Divided by 2. So this is going to equal 12 plus or minus 256, square root of 256, divided by 2. Now, before I allow you to use the calculator, we have to simplify this radical. Yes, sir. 16 times 16 is 256? No, sir. Is it? Yeah, actually, yeah, it is. Yes, good job. So this is going to be 12 plus or minus 16 divided by 2, which is going to equal 28 divided by 2, and it's going to equal negative 4 divided by 2. So x will equal 14 and negative 2. So it turns out we could have factored that from the beginning. See, whenever you have nice, pretty numbers like this, that means that you could have factored it. But it wasn't something that you readily saw. It was easy to see. So you went to the quadratic formula. No big deal. But do you see how long that takes? It is not difficult at all. But if you can factor it, if you could solve it by completing the square, if you could solve it by square rooting, I would do that first. But this is the procedure, always. Yes, sir. You can use a calculator at the end. For this one, there was no need for a calculator. The radical 256 is 16 times 16. Figure it out. You're going to have to figure it out. Okay? You could break that down. You could have started breaking it down. Okay, there are skills that you know to do that. Let's do another one. Yes, sir. Easy. Oh, yeah, no, it's long, but it's easy. Abso-freaking-lutely. Absolutely. Like this one. Would you even use a quadratic formula for this? Absolutely not. To be honest with you, we're going to go ahead and do it just to show you the procedure. But if this was a test or a quiz and they just said solve, okay, like I was saying, if this was a quiz or a test or an SAT, I would factor this. X plus 11 squared, X is going to equal 11, period. I mean negative 11, done. That's it. But we're trying to learn the quadratic formula. So negative b plus or minus the square root of b squared minus 4 times a times c over 2a. See, in this case, it's so much easier just to factor it. But again, I regress. Well, then if it's unfactorable, son, that's the whole point. Yeah. I'm just showing we don't need a calculator. 484 minus 484. Okay, good. Over 2. So that's going to equal negative 22 over 2, which equals negative 11, which we had gotten in our head in about 3 seconds. So the quadratic formula, very powerful, very awesome. It will always give you the answer. Always. But if you can factor it or solve it an easier way, I definitely would, in my opinion. Okay, let's continue. Yes, sir. What's up?
The formula is just like the axis of symmetry, right?
No, the formula has nothing to do with the axis of symmetry. What are you talking about? This is negative b plus or minus the square root of b squared minus 4ac divided by 2a. The axis of symmetry is negative b over 2a. How is it that it has a part of it, but it's not like it? I wouldn't say, oh yeah, the quadratic formula is like the axis of symmetry. No, I would not say it. Don't say it to any of your friends, please. Do not say it to any of your friends. Oh yeah, it's like the axis. Oh yeah, it's like the axis of symmetry. No, it's not. Not at all. Not at all. It has a b and a 2a in it. Whoop-de-doo. So does birthday 2. Birthday 2 has a 2 and a b and a. I know I'm on video. I'm not embarrassed. There's no big deal. People in the YouTube world are going to like this interchange, because people in the YouTube world know the axis of symmetry formula has nothing to do with the quadratic formula. It has a b and it has a 2a in it. That's about it. All right, now, there is a very important part about the quadratic formula that you should really understand. It's called the discriminant. The discriminant is part of the quadratic formula. It's the square root part. It's the b squared minus 2ac part. And the discriminant is very powerful. By knowing the value of the discriminant, you can know right off the bat whether it has one solution, two solutions, or no solutions. And that's pretty cool. That's pretty nifty. Because if you're looking for the solutions alone, a lot of times they will not ask you to graph it. I'm going to ask you to graph it on some parts, but in some parts, I just want the solution. For example, if NASA has a formula already for the trajectory of a rocket, they don't necessarily need to see the graph, but they definitely want to see how far away it's going to land, so they want the solutions of their formula. So in that case, if I don't tell you to graph, I just tell you to solve it, and you don't want to go through all of the mission of, you know, solving it and going through the whole quadratic formula or trying to complete the square, you could tell right off the bat, hey, wait a second, is it even worth continuing? Do I even have a solution? Is it a no solution? What's going on here? So the discriminant, when the discriminant is equal to 0, just like in example 2, if you notice, we had 484 minus 484, the discriminant was 0. Okay, you have exactly one solution. Hence, the solution in that last example was negative 11. Okay? When the discriminant is greater than 0, then the equation has exactly two solutions. Correct, sir. Like our first example. Very good, my man. Very good. And when the discriminant is less than 0, then the equation has no solution. Or rather, no real solution. It's got imaginary solutions, but that's not what we look for. There's no real solutions. Yes, sir. Sir.
The only reason for doing this would be if squared minus 4ac is less than 0.
Well, the question was, why would you do this? Okay, you see a crazy function in front of you. And you know, okay, I'm going to have to go through the quadratic formula. Because I'm not going to be able to factor this. I'm not going to complete the square. It's too much. You could figure out right quick the discriminant. If you know that the discriminant equals 0 or greater than 0, you know that you got to continue. Go ahead and use the whole formula because you're going to have at least one or two solutions. If it equals 0, continue because you're going to have one solution. If it's greater than 0, continue. You're going to have two solutions. If it's less than 0, you can stop right there. You don't have to continue with the whole function because I'm looking for the solutions. And if you already could tell from the discriminant that it's no solution, done. Sir, and then sir. Thank you, son.
So we can just write down that our square root looks less than 0 and then say there's no solution, you would accept that.
That's exactly what I said. Yes, sir. Yes, sir. This is something you would do while you're doing the quadratic formula was the question. You could do it for any time. But yes, I usually do it when they're looking pretty ugly. And actually, I don't even really separate this. I'll just start the whole quadratic formula. And if I see that in my discriminant it's going to be a negative, I'll stop the question right there. And I'll just put easily, no real solutions. Done. You cannot be marked wrong for that. Now, if I tell you to graph it, you still got to find the axis, the y-intercept, the vertex. But there's not going to be any solutions. Yes, sir.
If we have like an I in the solution.
You will not have an I in the solution. You will have a negative discriminant. And in that case, it is no real solution, sir. Thank you, my brother. Okay. I don't want the imaginary solutions here. We don't need them. We want the real solutions. Does that make sense? Okay, let me show you some of those. Let me show you some of those, guys. We had some more time, so that's good. Okay. For example 3. What if I tell you solve 2x squared plus 4x minus 5 equals 0? Okay, looking at this really quickly, if we were trying the Cuban method, it'd be negative 10. That would be the new C. Anything times anything equal negative 10, but when added together is 4. Unfortunately not. We could divide everything by 2 and then do completing the square, but you're going to have a lot of fractions in there. This is a perfect candidate for quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c. You with me, guys?
Yeah.
Divided by 2a. Go ahead and plug that in, please. Okay, from there, you got negative 4 plus or minus the square root of 16 plus 40. So you got square root of 56 over 4, which then equals, okay, let's look at the square root of 56, gentlemen. Square root of 56 breaks up into, or 28 and 2, and then 2 and 14, and then 2 and 7. So you got two 2's, right? So I can pull out 1, 2. So this is going to be negative 4 plus or minus 2 square root of 14 over 4. Now from here, remember basic elementary math. This is a distributive property. So this 4 gets distributed to this guy and to this guy, giving me a final answer, which is going to look like this. Negative 1 plus or minus the square root of 14 over 2. Because negative 4 divided by 4 gave you the 1. And the 2 over 4 here, the 2/4, that reduces to 1/2. Now, the answer here that I have, negative 1 plus or minus square root of 14 over 2, that's the answer for the test. That's what I want. That's what I want. You don't have this, then the extra credit, which I'm going to be nice enough to give you, you're never going to get the extra credit. So now, how do we do this? This is going to be negative 1 plus the square root of 14. All of that whole sum divided by 2, which gives me 1.37. I said to round to the hundredths always. And negative 1 minus the square root of 14. That difference divided by 2. Oh, wait. I did this wrong. Yeah, I did this wrong. Because I'm not paying attention. My bad. Negative 1 plus parentheses square root of 14 divided by 2. Sorry about that, folks out there. That's 0.87. I was not paying attention. My bad. Thank you. And negative 1 minus parentheses square root of 14 divided by 2. That was a huge mistake that I made. And it's very important for you to understand the mistake that I made. I'm going to go ahead and show you what I did. I went ahead and added the numerators and I divided it by 2. That was false. That's what's happening here. What's happening here is negative 1 is being added to parentheses square root of 14 over 2. And negative 1 is being subtracted from parentheses square root of 14 over 2. My bad. Thank you. Yes, sir. No, because I have too many other things here. The question was, can you show me an example with decimals? It's really the same exact thing, son. For decimals, I'm not a monster. I will let you use calculators all the way through, except I still want to see, though, my final product in radical form. I want to see that. I will not budge there. Okay? Let us do another example. Let's say I tell you, please, to solve x squared minus 4x equals negative 13. As always here, folks, we're going to have to first set it equal to 0. So this becomes x squared minus 4x plus 13 equals 0. You can't factor that. So negative b plus or minus the square root of b squared minus 4 times a times c over 2a, which equals 4 plus or minus the square root of, wait a second, this is 16 minus 52. What's 16 minus 52? That's 16 minus 52 is negative 36. Okay, what do we know there now? We can stop right there and say no real solutions. But again, on the test, I want to see all the work that you got to it. Okay? All the work. And
Would you change it to 2 over 1?
I'll tell you what else I can do. Actually, I'm going to be nice. I'm going to be really nice. If you get to there, I'll give you the credit. If you go ahead and give me the actual solution, I'll give you a little tiny extra credit. So this would become 4 plus or minus 6i over 2, which equals 2 plus or minus 3i. So if you do that part for me, I'll give you a little extra credit as well. The question was, what if I give you the solution? There are no real solutions here. If you get this part and you get to this far and you just say no real solutions, you get the answer right. If you get to this part, you get a little bit of extra credit.
That's extra credits.
Okay, I changed my mind. There is no extra credit for this now. What's going to happen is you're going to write this exactly the way I have it here. You guys are going to have to start learning how to listen, and that's it. So no extra credit for that. How about that? None. This is the way I want my answer now. I want no real solution, and I want the actual imaginary solution, period. Any questions now? Oh, okay, good. I'm glad that it's clear. Great. Now, the last thing that I want to go over with you guys, you have to know when and where to use what method, okay? So, when we're solving quadratics, we have a lot of tools here, okay? The first tool we have is graphing. Graphing is really important. You're going to have to use it. It can be used, but it's not the best one to use, okay? Use only if an exact answer is not required, okay? It's best used to check the reasonableness of what you found. So, use if an exact answer is not required. They just say estimate the answer of this quadratic function. Yeah, graph it. You have an estimate. Okay, 2, factoring. You can solve a quadratic equation by factoring. I love factoring. Okay, I love factoring. And I use factoring. Use if easy to factor. And we have used a lot of skills on factoring. We know how to recognize perfect square trinomials, difference of squares, you know the Cuban method. So hopefully by now factoring is easy. If you could recognize it, use it. So use it if it's easy to factor, if it's recognizable to you. Okay. You also have the square root method. You can take the square root from both sides. Similar to how you finish up completing the square. And use for equations with a perfect square. Okay? When a perfect square is equal to a constant. So use when a perfect square is equal to a constant. For example, like if I tell you x plus 2 squared equals 9. Take the square root of both sides there, subtract 2, boom, you're done. That's easy. Square root method. Okay? Completing the square. We know how to complete the square as well. It's useful when it's not factorable, but you don't want to put it into the quadratic formula. So I would say use if not factorable and numbers are easy. I would use the completing the square. It's faster. And the last but not least, of course, is the quadratic formula. And the quadratic formula you're going to use when all other methods are just too tedious. And of course, tedious being they just take too long, too many steps, too many fractions, too many decimals, too many whatever. And that's when you use the quadratic formula. All right? Thank you very much, and have a great day, guys.